Yeah, it's kind of weird, like this topic. You it'll seem like if you go a Calc 3 route after this course, it'll seem like this topic is like, oh, we just did that for fun, I guess. And it'll come up maybe once or twice in Calc 3. I mean, towards the very end of the course, maybe a little bit more, but throughout the course, maybe a couple of times, just for convenience. And there will be situations where we won't even need to use any of these concepts, but we'll opt to do it. Right? Differential equations, you'll see it a little bit more. So some people use that as a determining factor. They're like, I hate this topic, so forget that. I'm not going to do that anymore. But it's really not that bad. It's just a different animal. All right. So the one thing that you have to do is be completely open-minded to the notation. All right. The notation is so incredibly important in this topic, and I honestly think it's the key to understanding everything. All right. If you can understand the notation, then everything else kind of falls into place. All right. Because I'll tell you right now, the first time I saw this stuff, I glossed over the notation. And it was like, oh yeah, I think I got it. Yeah, you're just making a list of values, it's fine. And then before I knew it, the teacher was writing what looked like a complete foreign language up on the board. And I was like, yep, here we are now. I guess I'll Google it when I get home. Yeah, there was no Google back then. So yeah, you've in many cases experienced that. So yeah, the notation. Starting with z plus. Z plus is a simple one. It's just saying the positive set of positive integers, right? So it's not really so much that I'm introducing this for you to make use of the z plus, as much as it is for you to understand what you're seeing when I use the z plus. Although when I say to write the domain, you'll need to use the proper notation. So there are small instances where you'll need to do it. But what this is telling us is that the set of integers which go from negative infinity to infinity, we're ignoring anything that's negative, and we're also ignoring 0. All right, and the reason why is because when we're talking about sequences and series, one of the elements that we're getting into is the position within a sequence. All right, so if I were to tell people to line up or to count off, I'm sure we've all been in that situation where it's like, all right, everybody count up, and you're like 1, 2, 3, 4, 5. Nobody starts with 0. All right, so it's like, okay, count off 0, and you're like, oh, dude, what are you doing? Count off -7. Get out. You start off at 1, right? So that's what this is getting to. A sequence is a function whose domain is set in the form of, look at that. It's beautiful. N belongs to the set of positive integers such that n is greater than or equal to n. All right. So it's like, whoa, n is greater than or equal to n. So that capital N represents a positive integer, so a particular positive integer. So if I were to say, I could look at, well, I have an example, but n is equal to 3. For example, this is limiting or restricting my domain to the positive set of integers with the condition that n would have to be more than or equal to 3. All right, you're establishing the position or the relevant positions within the sequence. Right? So if I were to say, everybody get in line, count off 1 through 31 or whatever it is, but then I would say, okay, I just need from the 10th person on, which is a possibility. The first 9 people are for one group, and then everybody from 10 on is something else. All right? If that's the case, then I've just established capital N to be 10. All right? So it's just starting with that position within the sequence and then going on from there. All right? So we have dealt with functions of a real variable, and what we're going to do is take our knowledge of those real variable functions and apply it into this realm of sequences. And I'll show you some techniques on the calculator. That's deja vu. I feel like I've said that before. But there's a whole sequence mode that's built into your calculator that handles all this stuff. But also we can use the parametric mode to do some of this stuff force also. Maybe I think maybe I'll just stick with the sequence mode. All right. So we have a sequence defined by f of n is equal to the square root of n plus 3. If I'm saying that the domain is a set of positive integers, then, and that's the default, by the way, positive integers, and the restrictions happen from there. All right. So it's never like negative infinity to infinity and then drop off a -2, a positive 13, whatever. This is the default. We're starting with our base set is the positive integers, and if we're going to restrict it, we're going to restrict from that subset of the real number system. All right. So starting with 1, plug it in, I get a 2. Plug in a 2, I get a √5, and a √6, and so on. All right, simplify or not, and so that's the whole tab thing, because this should be and so on. Sometimes a sequence is a finite sequence where you're only going to a particular position. Maybe I only want the first 10 values, the first 4 values, the first 6 values, whatever. But the ... is indicating that I could go on and on and on, right? And so we need to account for that. So notation-wise, we might say f of capital N, f of n plus 1, and so on. But really, if you dive into what that's talking about, this is talking about the set of consecutive positive integers. All right. So if n is equal to 1, then we're looking at f of 1, then f of 2, f of 3, f of 4, should be a comma here, and really only 3 dots. This is overkill. So comma, ... comma. Then I would plug in, I'm going all the way to the nth value. So you kind of run into the issue there of where does that end up? All right. Well, the nth value is the lowercase n. If I'm just assuming that capital N is equal to 1, then what we end up with here is a nice little cancellation. F of 1 plus n minus 1 is going to simplify down to just f of n, lowercase n. All right. Now, this opens up a whole other can of worms, because I have the ... after this, which is telling me that I can continue on, because you can get to the nth value, but then you could also keep going and go one more. So n plus first value, n plus second, n plus third, n plus fourth. So there's no end to this unless you dictate that there must be an end to it. All right, and that comes in the structure of a problem. All right. So instead of writing f of n, we're going to write f sub n just for convenience. Makes life a little bit easier. Not a lot easier, just a smidge easier. And we're going to move away from f notation and go to ABC notation just to distinguish this from other types of functions. Because what's going to happen, like I was saying before, is we're going to use our knowledge of real valued functions and use that to help us to draw conclusions about these sequence functions, right? Functions that are related to sequences and series. Right? So then the question would become, well, if I'm already using f of x to represent, let's say, for example, the natural log of x, and I'm using that to approximate a particular sequence, how do I distinguish that from the sequence itself? So for that, we go into the realm of A's, B's, and C's. So A sub n, B sub n, C sub n, and so on. All right. So actually, let me take this opportunity to show you how to do this in the calculator. In a few minutes, because I was teaching stats in another class, and I think my settings are messed up too. So it's kind of annoying. Anyway, the sequence function actually works on the home screen, so I can show you that later too. I'll do it all in one shot. It's just once I deleted that video, I knew all hope of salvaging that was lost. But for something like these examples here, finding the domain of sequence, remember the idea is that it's a default to the positive integers. All right, so once you have that in mind, the only thing that you're looking to do is restrict those positive integers, if applicable. Right, so in the case of number one, it's an even root, so I can't have a negative under the radical. So I need n minus 4 to be greater than or equal to 0. All right, in which case, if I solve, I get n greater than or equal to 4. All right, so that's my restriction, and it's a pretty simple restriction. Bearing in mind that there's nothing wrong with having a negative under an odd root. Right, so if it's a cube root, fifth root, whatever, you could have a negative under the radical, and there's no problem. It's only the even roots. Right, so what I would state here is my domain is that n belongs to the set of positive integers. Now you could use the colon for the such that, or you could use a vertical line. I like the vertical. I go back and forth, vertical line or the colon. All right, the vertical line is kind of like a little partition mentally for me, so I kind of like that one a little bit more. Such that n is greater than or equal to 4. And, just do the best you can with the squiggly brackets. But this is set notation, and part of the notation is the squiggly brackets. So it's like, do we have to include those? Yeah. Do you have to do them well? No. Just make sure that they don't look like regular parentheses or regular square brackets, and you're fine. Right? So if you're going to make some crappy looking squiggles, that's fine. Nobody's going to lose any sleep over it. All right? It's when you just neglect it, that's where you run into trouble. All right. Now, in terms of the first 4 values of the sequence, well, the domain is a key ingredient here, because if I didn't identify that my domain, bless you, starts at 4, then I might try to put a value of 1 in for n. But the first value of my sequence here is going to be a sub 4, which is going to give me a result of 0. Then a sub 5, which is going to give me a result of 1. A sub 6, which is going to give me a result of 4th root of 2. And a sub 7, which is going to give me a result of 4th root of 3. All right. So did I actually need to state the domain in order to make that realization? No. But it didn't hurt. In number 2, slightly different situation. Yeah, there's a restriction to this function if it were a real valued function. I might say 3n minus 2. Well, I don't want that to be equal to 0, because then it's undefined. If it's undefined, that would be bad news, regardless of what topic we're working on. So n can't be equal to 2/3. But n couldn't be equal to 2/3 anyway. All right, so my domain here is n belongs to the set of positive integers. All right, because 2/3 wasn't a positive integer to begin with. Now, if you wrote such that n cannot be equal to 2/3, is it wrong? No. It's irrelevant. I'm concerned that you maybe don't fully understand the concept, but it's not wrong because you're telling me something that it can't be. All right? I mean, you could also tell me that n cannot be a negative 27. I know, it can't be, because it's got to be a set of in the set of positive integers. It's irrelevant, it's not incorrect if you include it, but obviously something you want to stay away from. All right? The first 4 values. So for this one, you might want to go to the calculator. All right? For now, we're living in function mode because I haven't effectively taught the sequence mode, parametric and sequence modes yet. So you just put it into Y1, go into your table, and only get the integer values, positive integer values. So we'd be looking at A sub 1, 2, 3, and 4. So 5, 3/2, 4/5, and 9/13. All right. Number 3 is a very intimidating looking one, but it's no more difficult than the previous one. So I'm going to put a nice juicy star on that one, and also number 4.